Hey, good afternoon, class. So, I decided that I will just record the discussion for the experiment number 6 or the lipid experiment para naman mabalik-balikan nyo siya if ever na gusto nyo ulitin yung discussion. Okay? So, let's start with the introduction. Okay? So, it says here, okay, first page of your experiment, says here that lipids constitute a large heterogeneous group of unrelated physical and chemical substances classified together because they are fat-like substances and they are insoluble in water and are soluble in organic solvents. Okay, so when you say heterogeneous, okay, so meaning they are composed, the structures of your lipids are very different from each other. So magkakaiba-iba sila. Okay, they don't have a general formula because each structure of your types of lipids have different components. Okay, so they have different components. So when you say heterogeneous, they are composed of different elements, or they have a widely dissimilar elements or constituents. Okay? So, soluble sila your lipids are soluble, very soluble in organic solvents, okay, or solvents that contain carbon in its composition. Okay, so kaya nga, diba, yung organic substances natin are composed of either carbon, hydrogen, and oxygen, and other more elements. But the most important atom in your organic substances and solvents is the presence of carbon in decomposition. Okay, so ano ba yung examples natin ng organic solvents? You have chloroform. The chemical formula for your chloroform is CHCl3. Your ether, C2H5, then close parentheses, 2O. And then you can just search this class, no? And then you have carbon tetrachloride, CCl4, and then you have alcohol, C2H5OH, and lastly your benzene. Okay, so the structure of the benzene is actually very unique because your benzene is a ring, no? It is a hexagon ring, okay? Or para siya yung pyranose, no? Or pyran ring. The only difference is it has 3 double bonds in the ring. Okay, so tatlo doon is single bond sa ring, and then another 3 naman is double bond. So C6H6, yan yung inyong benzene. Okay, so they are essential constituents of practically all plant and animal cells. So in human body, lipids are found mostly in the cell membranes, in brain and nervous tissues. Okay, fatty acids are constituents of lipids. Okay, so sabi nga natin, fatty acid is the most common constituent of lipids. May isang exception lang, dun sa ating steroids. Okay, so your fatty acids compose fats or oils, your waxes, your phospholipids, your herbicides, myelins. However, some so-called lipid derivatives, just like your steroids, do not contain fatty acid radical, okay? Although they possess the same physical properties of fats like their solubility characteristics. So, ano ba ibig sabihin nito, class? Okay, so, lipid derivative yung tawag sa steroids because ano yung structure nila? They contain the steroid nucleus. Okay? So, ang function nila, ang physical properties ng inyong steroids are just like fats. Okay? But in their structure, ang main component ng structure ng inyong steroids are not fatty lipids, but instead, the steroid nucleus. Okay? So, yung 4 na ring na magkakadikit-dikit. Okay? So, included yun sa lecture. So, fatty acids found in nature have even numbers of carbon atoms in the chain. Double bonds in unsaturated fatty acids are readily attacked by halogens. So, ano nga yung halogens? So, if tingnan nyo yung periodic table, you will see the halogens. So, these are the fluorine, the bromine, the iodine, okay? And then you have the chlorine. Kasama din nila, astatine, and yung pinakahuli, tennessine. Okay? So, FCl, Br, IAP, TS. Okay? So, sila yung mga halogens. And your halogens, when present with unsaturated fatty acids, they actually bond with the double bonds found in the unsaturated fatty acids. So, nangyayari, nawawalan ng double bond yung mga unsaturated fatty acids and they become saturated fatty acids with or bonded to halogens. Okay, so this is the basis of iodine number determination, which is a test to detect the degree of unsaturation of fats and fatty acids. The more unsaturated the fatty acids, the more double bonds it has and the more halogen it will absorb. So, kung mas maraming double bonds na present sa isang unsaturated fatty acid, mas marami ring halogen ang kanyang natitake up. Okay. So, let's go to test number 1, solubility test. Okay, so, ang procedure ng solubility test, you will see. Okay, so, meron siyang dalawang test, no? Subtest. Yung subtest 1 and subtest 2. So, magkaiba-iba rin yung ginamit na reagent and sample. Ha, class? So, wag yung, don't mix the reagents and the samples in your test or subtest. Okay, so una dito sa test 1 natin. So in overall, your solubility test is a test based on the property of solubility of lipids in organic solvents and insolubility in water. So, bakit insoluble ang inyong lipids sa water? Because the water is not an organic solvent. Wala siyang carbon, okay? So, while your inorganic solvents. So, dapat ano ito? Organic solvents. Correction ito siya, class, ha? Okay? So, ayan. Organic ito, organic solvents. Okay, don't worry, I will just correct this and then I will post another, or kahit kung na-download nyo na, scratch nyo na lang yung in dyan, organic, this is organic. Your lipids are soluble to organic solvents and insoluble to inorganic solvents. Okay, ha? So, malaman ko if hindi nyo pinanood itong video, kasi baka mali ang answer niyo sa quiz or sa exam. Okay, so, yan, alisin yung in dyan. This is just organic solvents. Okay, so for subtest number 1, okay, for subtest number 1, okay, so ito yung sinasabi ko, class, yan. Alisin niyo yan siya. Organic solvents yan siya. Okay, so, for subtest number 1, the principle is the oil will float on water because of lesser specific gravity. So, ano ba yung procedure? In pipette 1 ml of the following solvents in separate stopper vials. Distilled water, ethyl. Okay. So, you have your reagents. Okay, ang reagents is water, ethyl alcohol, ether, chloroform, benzene, 5% HCl, 5% NaOH. Okay, samples used. You have your cotton seed. For both subtests, itong binigay ko na reagents and samples for both subtest 1 and subtest 2 na ito siya. Okay, so principle ng ginawa sa una is you slowly drop 1 to 2 drops of cottonseed oil in each vial and shake thoroughly. Record the time required for the oil to dissolve. So, ang titingnan ninyo sa subtest 1, dito sa solubility test is whether your cottonseed oil is soluble on the given reagents. Okay, so kaya nga, you will take note of the time and the oil dissolved. Pero since hindi natin siya perform, we will not include the time, okay? Since na siya kasama. So, ano isasama natin? If yung result niya, if nag-dissolve ba yung cottonseed oil doon sa different sample or sa different reactants natin. Okay, so kapag kapag yung oil mo is not dissolving doon sa ating reagents, then it will float on the water because of the lesser specific gravity. Mas less yung specific gravity ng oil compared to water. Kaya, lulutang yung oil on the surface of the water. Okay? So, form siya ng globules. Okay, so, let's see. Sa result natin, water, since water is inorganic, then your oil will not be, or your cottonseed oil will not be soluble to it. So, merong, ang kanya reaction is insoluble. And there will be formation of globules of oils. When you say globules, class, these are the small formation of circle shape, no, ng inyong oils in one drop sa water. Next, you have ethyl alcohol. So, yung ethyl alcohol is an organic solvent. So, soluble siya. So, one phase lang. Kapag one phase lang, class, meaning, your ethyl alcohol and your cottonseed oil actually mix together, okay? Kaya isang phase lang yung makita mo. Parang ganito. Diba? So, walang different phases. Walang nasa taas, walang nasa baba. Okay? So, kapag may formation of globules kasi, two phases ang nandyan kasi naghiwalay yung oil and yung inyong water. Pero dito sa ethyl alcohol, one phase lang siya because your ethyl alcohol and your cottonseed oil mix together. Okay, soluble siya. The same with your chloroform. So, translucent yung color na form and one phase lang din. And the same with ether because your ether is an organic solvent. So, one phase, the appearance of the solution is clear. And the same with your benzene. Okay, soluble din siya to benzene, your cottonseed oil, and it forms one phase. Now, you have HCl and NaOH solutions. Okay, 5% HCl, 5% NaOH. So, these two are an example of inorganic substances or solvents. So, therefore, hindi soluble yung inyong cottonseed oil dito. So, there will be formation of globules or two-phase liquids. Okay? So, by the way, class, doon sa inyong exam or quizzes, included yung mga concentration ng inyong solution. Kung nagbigay siya ng concentration, for example, ito, 5% HCl, then meaning I will expect that on your answers, you will also write the 5% HCl. Okay? Because this is very specific. Ano yung concentration ng solution na yun. So, kasali yan sa sagot ninyo. HCl lang or NaOH is considered wrong. For example, tinanong kayo what are the different reagents found in test 1 or sub-test 1 in solubility test. So, dapat included yung 5% HCl, 5% NaOH. Okay, so objective nitong sub-test 1 is to test the solubility of oils in different solvents. Explanation niya, because fats are not dissolved in water due to their nature, non-polar or hydrophobic, but they are soluble in organic solvents, such as chloroform, benzene, and boiling alcohol. Different lipids have ability to dissolve in different organic solvents. So, ito kasi siya, class, this is the explanation. No? Different solvents will have different time, no? As a result in dissolving your cottonseed oil. So, iba-iba yung action or bilis ng action ng inyong different reagents or organic solvents towards cottonseed oil. So, may isang mabilis niyang ma-dissolve, yung cottonseed oil. Meron din isang matagal. Okay? So, yan yun. Different lipids have the ability to dissolve in different organic solvents. So, this property enables us to separate a mixture of fat from the other, or from each other. So, positive reaction niya, formation of one-layer homogeneous transparent solution. Okay? So, meaning the oil is dissolved kasi one layer lang. Homogeneous, ano ang meaning ng homogeneous? Isang phase na pareho. Okay? Kabaliktaran ng heterogeneous. Okay? Heterogeneous means composed of different or many elements. Homogeneous is composed of only one similar element. Okay? So, meaning yung, ganito ang example ng homogeneous. Isang phase lang, wala kang nakikitang ibang included sa kanya. Okay, next, negative reaction naman if it form two layers or heterogeneous yung inyong solution. Okay? So, separated yung oil from the solvent. So, meaning the oil is not dissolved. For the second part, anong ginawa sa second part? So, dalawa lang, no? You've placed, so meron kang isang bond paper, and then you've placed 3 drops of each mixture of cottonseed plus ethyl alcohol, and then for the other mixture, you have cottonseed plus ether. Okay, so both your ethyl alcohol and ether are actually organic substances or solvents. Therefore, cottonseed oil will dissolve on the two solvents. Okay? So, all lipids are greasy in nature. Ito yung principle niya, class. Therefore, oil does not wet the paper. Okay, so ang dito, kapag hindi na-dissolve yung oil mo dun sa given solvent, then it will not wet the paper. Kasi nga, lipids do not leave, no? Or do not penetrate it doesn't penetrate the paper because of its hydrophobic nature. Okay? So, since nag-dissolve siya sa ethyl and sa ether, then you will expect that it will leave a wet mark on the paper for both mixtures. Okay? So, pareho silang positive. So, your cottonseed ethyl alcohol will wet the paper because cottonseed is soluble in ethyl alcohol. The same with your ether. Sino? Okay, so bago lang in-announce na available na daw ang course pack for anatomy for anatomy and also the lab exercises. So, pwede nyo nang bilhin class sa logistics, ha? Pag pumunta sa class office, kukunin ang course pack for anatomy and also lab exercises for anatomy doon sa logistics. Available na daw. Okay. Let's continue. So, the second test is test for unsaturation of fatty acid. So, ito class, may difference no, sa answer ng group number 2. Okay? So, it is also composed of 2 subtests. You have subtest 1 and subtest 2. Okay. So, ano ba ang ginawa sa subtest 1? To 6 drops of carbon tetrachloride and 3 drops of oleic acid. So, ipaghalo mo muna ang carbon tetrachloride and oleic acid. Then, you will add drop by drop the bromine water. Okay? So, ano ang i-notice? The production of faint orange color. So, ano ba ito siya? Para saan? Your bromine water in Cl or carbon tetrachloride is a test to determine if the sample lipid is saturated or unsaturated. Okay? So, anong nilagay ko? Result, 3 drops of bromine water before the color change occurred. Okay? So, ganito kasi yan, class. Yung oleic acid ninyo is an unsaturated fatty acid. Correct? Unsaturated siya. So, meaning, your bromine water, meron siyang bromine. Okay? Your bromine is a halogen. So, sabi ko kanina, halogens will bond with the double bonds found in your unsaturated fatty acids. So, yung color ng inyong, the color or the original color of your bromine water is orange. Okay? Orange siya. Now, if drop by drop lang naman. So, sa first drop, pag drop mo, the color of the bromine water is orange. Pag drop mo doon sa solution ng inyong oleic acid and chloroform, mawawala yung kulay ng orange. Okay? Magiging colorless. Why? Because the bromine water or the bromine in the bromine water was taken up by the unsaturated fatty acid, oleic acid, doon sa double bond niya. So, nawala na yung color ng bromine water, which is orange. Kasi nga, kinuha na yung mga bromine molecules at nag-bond doon sa double bonds ng oleic acid. Now, second drop, ganun din, colorless pa rin. Meaning, hindi pa saturate or hindi pa napuno yung double bonds doon sa oleic acid. Pagdating ng third drop, it turned into a color orange. Meaning, hindi na nag-change yung color for the third drop, hindi na nag-change yung color ng bromine water to colorless or transparent. That means that all the double bonds found in your unsaturated fatty acid, oleic acid, has been bonded already na. Napuno na yung double bonds doon sa oleic acid, okay? Kaya, wala nang mag-cater doon sa molecules or sa bromine molecules mo, okay? So, as is yung color niya, hindi nag-change. Kasi nga, hindi naman siya na-take up ng double bonds kasi puno na yung oleic acid. So, ganun dapat yung explanation no, for this test. So, ang positive ay, ang kinukuha mo dito is how many drops, no? So, binigay ko na 3 drops. So, maliit lang, no? 3 drops lang. Why? Because your bromine or your oleic acid contains only ilang bond lang ang meron sa kanya. Sa formula niya, isa lang, di ba? If I'm correct. Okay, sa oleic acid ninyo. So, lesser yung number of double bonds found in the structure of your oleic acid. Okay, kaya, maliit lang na drop, napuno na siya agad ng bromine halogens. Kaya, mabilis nag-change yung color niya. Now, if ang gamit mo, for example, is an acid or a fatty acid or a lipid that is very, very unsaturated, meaning composed siya ng napakaraming double bonds sa structure niya, then that means mas more than 3 drops pa no, ang kailangan mo na i-add na bromine water before siya mag-turn into orange. Kasi nga, mas maraming double bond na kailangang lagyan ng halogen, which is the bromine. Okay? So, if ilang drops na yung nalagay mo, but still the solution is colorless or transparent, that indicates that the lipid is an unsaturated lipid or napaka-super unsaturated lipid nung sample. And thus, the presence of the double bond is responsible for the change in color. Okay? So, ayun class. Yun yung explanation dyan. So, yan. The halogen, ito explanation, the halogen Br or bromine was taken up by the double bond present in oleic acid. So, anong reagent natin? You have bromine water containing your bromine halogen. And then you have your carbon tetrachloride. And the sample is oleic acid. Final result. Ano ba talaga yung result? Orange color, hindi colorless. Kuha class, baliktad yung explanation. No? Orange color yung final. No? Kasi there is a lesser number of double bonds found in oleic acid, thus the color changed very fast. 3 drops lang. Indicating that the oleic acid is already full of bromine and thus the solution turns orange in color. So, ito class, usually, you will not stop no, until you are getting the orange color. So, hanggat hindi mo nakukuha yung orange color no, sa solution, so tuloy ka lang ng tuloy ng pag-drop ng inyong bromine, water. Okay, so binibilang kasi yan doon sa laboratory kung ilang drops yung inyong nalagay sa solution. Okay, next is for the sub-test 2 of test for unsaturation of fatty acids. The procedure is into 3 test tubes or stoppered vials, place 2 ml of chloroform and then add each test tube. Okay, so mag-prepare ka ng tatlong test tubes. You will add 2 ml of chloroform for each test tube, and then for each test tube, you will be placing 4 drops of 0.2 grams of palmitic acid, oleic acid, and cottonseed oil. Okay, so shake each tube thoroughly to dissolve the content. So by drop, kapag nag-drop ka class or naglagay ka ng inyong samples, kailangan ng shaking. Okay, so after nun, if na-shake mo na yun lahat, add 4 drops of Hanus iodine solution to each test tube and record the time in seconds for the color to disappear. So, ito na yun, class. Ito na yung ang final product or final result mo is dapat colorless. Ha? So, ang final product sa subtest 1 is orange color. Ang final product for subtest 2 is colorless or transparent. Okay? So, dapat yung pink color, tandaan, the color of your Hanus iodine is color pink. Okay? Hot pink. Ganyan. So, from being pink, dapat ang final result mo is magiging colorless. So, for reagents na ginamit, chloroform and Hanus iodine. And then samples, ito. So, class ha, huwag kalimutan yung 0.2 grams, very specific yan, of palmitic acid and oleic acid. And then, 4 drops para sa cottonseed oil. Okay. So, objectives or purpose indicates the amount of presence of double bonds in the lipid sample. So, itetest nito kung gaano karami yung double bonds present in your palmitic acid or kung meron ba for your oleic acid and cottonseed oil. So, principle, all neutral fats contain glycerides that of some unsaturated fatty acid. These unsaturated fatty acids become saturated by taking up iodine. Okay? So, since halogen yung inyong iodine, it will be bonded to the double bonds. So, if that fat contains unsaturated fatty acids, it will take up more iodine. So, ito yung kanyang solution class. You see here, this is the structure of your lipid. So, may double bond siya. Now, i-add mo siya with iodine molecules. So, pag nag-add na, this is the final product. So, nawala na yung double bond, napalitan siya ng isang single bond, pero nag-add ka rin ng dalawang iodine in the first carbon and in the second carbon. Okay, so ito yung final product. So, this final product is actually colorless. Okay, so, positive reaction niya, discharge color, meaning ng discharge, nawala yung color niya from pink, naging colorless because of taking up iodine by unsaturated fatty acids or oil. So, ang final product for positive reaction is transparent. Negative reaction dito, no change in color of iodine. So, color pink. Okay, comparing unsaturation. So, ito class, hindi ito na-change. So, ano pala ito? Number 6 biochem. Okay, ito yung hindi na-change na ito yung hindi na-change na PDF. Okay, wait lang class. I will replace this with a new one. Sandali lang. Okay, class. So, I am back. Ayan, napalitan ko na siya ng ito. Ayan, okay. So, comparing the unsaturation. Okay, so, doon sa inyong subtest 2, okay, the lesser number of drops, no, na kailangan ninyo in order to turn the solution or the color to pink. Okay. In order to turn the color to pink color, then the lesser the unsaturated. Okay. Ito yung dito tayo. Ayan. Okay, ito yung bago. Okay. The greater the number of drops required to discharge the pink color, the less is the unsaturation. Okay, so this means class, no, kapag mas maraming drops, no, ng iodine ang kailangan mo para ma-turn yung color or mawala yung pink color. Okay, so the lesser is the unsaturation. Or, wait lang. Ayan, so nalilito na rin si ma'am. Okay, so ang main point lang dito. Ano ang new dito? Okay, class. So, correct. Tama siya, no? Okay siya. Tama pala siya. Okay, so ito. This is the correct one. This is the newest. Okay, so, nalito ako kasi doble-doble. Pinalitan ko kasi yung mga correction ko. So, this is the final PDF. Okay? So, correct ito. The decrease in the number of, or the lesser number of drops required to turn it to pink color, the lesser is the unsaturation. So, diba, every time you will place or you will drop iodine solution to your to the palmitic acid, oleic acid, and cottonseed oil with your chloroform. So, ang color kasi na highness iodine is color pink. So, nawawala yung color niya. Kasi, tinitake up yung iodine molecules ng inyong samples. Okay? So, kapag tinitake up niya, the same way doon sa first subtest, nawawala yung kulay na color pink. Okay? So, when it comes to a point na after how many drops, hindi na nag-turn into colorless yung inyong solution. So, dahan-dahan, pag drop mo ng drop by drop, nagiging color pink na yung iyong solution. That means that the sample, your palmit or your oleic acid or cottonseed oil is already saturated. Okay? Kasi, na-banded na lahat ng double bonds found in its unsaturated structure. Okay? Yung mga double bonds niyan, lahat meron ng iodine. So, dito sa ating, sa results natin, your palmitic acid is saturated siya, no, na type ng lipid. Okay, so wala siyang double bond. So, ano ang color niya dapat? Okay, so ang color dapat ng inyong palmitic acid, unang drop pa lang, okay, sa pinaka number 1 drop pa lang ng inyong iodine, na color pink na yung solution. Okay, kasi nga, wala namang kukuha doon sa iodine molecules because your palmitic acid does not contain your double bonds. Okay? Wala siyang double bonds kasi saturated fatty acid siya. So, unang drop pa lang dapat sa palmitic acid, color pink na siya. So, negative. On the other hand, your oleic acid, okay? So, meron siyang contained na double bonds kasi unsaturated siya. So, meaning, kapag nag-drop ka ng iodine sa oleic acid, nawawala yung color pink. Okay? So, dapat yan, bibilangin mo pa, drop by drop by drop, hanggang sa maging color pink yung buong solution. So, ilang drops yung kinailangan para maging pink yung inyong solution. Okay? So, yun. So, positive ang ating oleic acid. Okay? Because it is unsaturated. Pero hindi ko na sinali yung number of drops dito kasi nga, hindi naman natin pinerform. Okay? So, doon na lang tayo sa ideas or sa positive and negative result. Okay? So, hindi ko na sinali yung number of drops na kinailangan dito. Next, you have 4 drops of cottonseed oil mixed with chloroform. It is also positive. Meaning, kapag nag-drop ka ng iodine sa kanya, nawawala din yung color ng iodine. Okay? Bakit? Because when you have that kind of result, that means that your cottonseed oil contains unsaturated components. So, ano ba yung components ng cottonseed oil? You have palmitic, steric, oleic, and linoleic. Okay, so, meron siyang components na unsaturated, and these unsaturated components your oleic and linoleic will be the ones creating a positive reaction for your subtest 2. Okay? So, kasi meron siyang oleic and linoleic, which are unsaturated lipids or fatty acids. Next, you have Acrolein test. Let's go to Acrolein test. So, the procedure for your Acrolein test, place each of the following mixtures in 2 separate test tubes. For test tube number 1 to 2 drops of glycerol added with a pinch of potassium hydrogen sulfate. Okay, so for test tube number 2, you have 2 drops of cottonseed oil plus a pinch of your potassium hydrogen sulfate solution or crystals. No? Crystals ito sila. So heat each tube over a low flame and note the color or odor. Reduce. Okay? So yung color dito class, palitan nyo yan ng odor. Kasi yung odor ang dapat na i-observe or ino-notify natin. Okay, so you have here a general equation. Oil or fat when undergoing heat, no, your triangle means heat, it produces glycerol and free fatty acid. Okay? So, naghihiwalay yung tandaan, oils and fats, these are composed, or your lipids are composed, have components glycerol and fatty acid. So, kapag nag-undergo sila ng heat, naghihiwalay yung glycerol component and fatty acid. Okay, so ang reagent natin, you have potassium. Pwede ito siyang bisulfate or pwede rin potassium hydrogen sulfate. And your samples, you have glycerol and cottonseed oil. So, the objective or purpose of your Acrolein test is to detect the presence of fats and glycerol or, more importantly, glycerol. Okay? Detection for the presence of glycerol. So, principle niya, when a fat is heated strongly in the presence of a dehydrating agent, such as potassium bisulfate or pwede rin potassium hydrogen sulfate, the glycerol portion of the molecule is dehydrated to form unsaturated aldehyde. Okay, so, kapag nag-undergo inyong fat ng dehydration because of the presence of dehydrating agent, itong KHSO4 ninyo, it will, or the glycerol part doon sa fat, ang glycerol part niya will be, what? Will be dehydrated and it will form another substance, and this is what you call the acrolein. Okay, your acrolein is an unsaturated aldehyde. Bakit siya aldehyde? It has the structure CHO or carbon, hydrogen, oxygen. So, ito siya, aldehyde coming from the carbohydrates. Okay? So, unsaturated aldehyde or unsaturated carbohydrate. Why? Because it contains the double bond between 2 carbons in its structure. Kuha. So, unsaturated siya. So, tandaan, ang presence ng isang double bond will make a substance unsaturated. Okay, so your acrolein, ang kanyang characteristic, it has the odor peculiar to burnt cooking grease. Yan yung naaamoy mo. So, yan yung pungent odor na nagpo-form. Okay, because your acrolein has a specific pungent odor. Okay, so ito yung reaction niya, general equation or reaction. Glycerol, the structure of your glycerol when it undergoes heating in the presence of an oxidizing agent. So, function ng inyong KHSO4 dito class is for oxidizing agent siya. It will form the structure acrolein plus 2 molecules of water or H2O. Okay, so itong dalawa actually ang product niya. But the acrolein is the one responsible for the burnt cooking grease or pungent odor. So, glycerol and cottonseed are both what? Positive. because both of them presented a pungent or burnt cooking grease odor. That means, bakit? Kasi yung cotton seed ninyo, it is composed of different fatty acids, saturated and unsaturated. And yung fatty acids natin, remember, is composed of what? Glycerol and, or yung oils and fats ninyo are composed of glycerol and fatty acids. So, cottonseed oil being an oil, no, it contains also glycerol. Therefore, will test positive sa acrolein test. Next, rancidity. Okay, so meron dito introduction ng rancidity. So, when you say shelf life, this is yung time, no, or range of time kung saan sinustore mo yung isang food and pwede pa siyang kainin. Okay, so refers to the length of time a product may be stored without becoming unsuitable for use or consumption, meaning hindi pa siya nagiging rancid. So every food that you buy in the market, no, they have certain shelf life. So, kaya nga meron tayong nakalagay sa mga pagkain na binibili natin na best at, no, or expiry date. So, yan siya. After shelf life of a product has been reached, the food undergoes processes which results in rancidity. Kapag sumobra na sa shelf life niya, yung isang pagkain, nagiging rancid na siya. Okay, so nagiging rancid, that it will result to rancidity. Ano ba yung rancidity, ma'am? This is the natural process of decomposition of fats, oils, by either hydrolysis or oxidation. Nagde-decompose yung inyong fats and oils, no, in the process called hydrolysis and oxidation. So, hydrolysis, with the use of water molecule, you will separate certain mixtures or bonds or linkages, and then for oxidation, this is the addition of oxygen atom sa structure, no, ng fats and oils or both. So your rancidity is the process of degeneration and converts fatty acid esters of oils into free fatty acids. So hinihiwalay niya yung fatty acids sa esters of your fatty acids. Okay? So, hinihiwalay niya yung fatty acids with the process of hydrolysis and oxidation. So, which gives rise to an unpleasant odor and taste in food. So, you have different factors of rancidity. You have the catalyst, you have the temperature, you have the amount of PUFA. When you say PUFA, this is polyunsaturated fatty acids. Okay? So, this means, from the word itself, poly, meaning it is a type of fatty acid that contains what? More than one double bond. No? Poly, maraming double bonds found in that unsaturated fatty acid. That is PUFA. Marami siyang double bonds in the structure. You have also time, yung length, no, nang nakastore yung food. And then you have light. Okay? Light has something to do with your food getting spoiled, okay? Or too much exposure to light will cause faster, no, rancidity. And then you have water, okay? Presence of steam or yan. So, unwanted water on food will also be causing rancidity. So, yan na yung hydrolysis class, okay? That is the hydrolysis. Okay, you have three types of rancidity. You have oxidative rancidity, or you also call it as auto-oxidation. So, ito na yung with the use of an additional oxygen. Okay? So, due to the auto-oxidation of PUFA, or polyunsaturated fatty acids, present in triglycerols by atmospheric oxygen on free radicals. So, pag sinabi mong free radicals, these are atoms, no, unstable atoms that can cause diseases. Okay? So, yung free oxygen galing sa atmosphere will be causing the auto-oxidation doon sa inyong fats and oils. that will cause oxidative rancidity. Okay, so including oxygen itong reaction na ito. Next, we have hydrolytic rancidity. This is the hydrolysis or enzymatic oxidation due to the contamination of fat by your enzyme lipase. By the way, lipase is an enzyme that catalyzes the rancidity of foods, okay, or fats and oils, leading to formation of diacyl or triacyl glycerols with free fatty acids. So, ang end product niya, the same with your oxidative rancidity, is aldehyde epoxide and peroxide. Next, so itong hydrolytic rancidity, pwede rin use ito is water, okay? So, dito yung water. Kanina sa oxidative, oxygen, dito, water, the presence of water, or the presence of enzymes like lipase. Remember, the lipase is very specific with your lipids, okay? So, ang dinadigest lang or ang kinakatalyze ng inyong lipase is only lipid. Lipid lang. Hindi niya dinadigest or hindi niya kinakatalyze yung reaction ng carbohydrates or proteins. Para lang siya sa lipids. Yung lipase, when it is present, it will hydrolyze or it will form a hydrolytic rancidity with your fatty acid or lipids. Next, microbial rancidity. This is caused by certain bacteria, molds, and yeast. So, siguro, no, doon sa, out of the 3 types of rancidity, ito yung pinaka-nakakadiri, yung microbial rancidity. Because these two, your oxidative and hydrolytic rancidity, these are natural processes na hindi mo na siya may iwasan. Okay? Pero hindi naman, walang presence ng pathogens dito. In your microbial rancidity, pwedeng ang gumawa ng pagiging rancid niya is bacteria, mold, or yeast. Okay, so they use their specific enzymes to break down the chemical structure in the oil, producing unwanted colors and flavors. Okay, so meaning hindi mo nilagay sa malinis na lalagyan yung inyong food or your oil, no, or fats and oils. That's why naabot siya ng bacteria, molds, and yeast. Okay, next, water needs to be prevented for microbial growth. Okay, so just like with your hydrolytic rancidity, yun nga, dapat when you store your fats and oils or your foods containing fats and oils, dapat walang presence ng water because it will develop or it will help microbes, no, to grow more faster. Okay, so this can be prevented by sterilization. You sterilize the containers on which you place your fats and oils. Make sure na malinis. Okay, next. Okay, so the results for your rancidity test or test for rancidity, you have the fresh oil and the rancid oil. Okay, so by the way, ano ang reagents dito? Ang reagent natin is ito, phenolphthalein, methyl orange, and pH paper. Okay, so yung pH paper is actually a material, pero considered siya as a reagent because it causes changes, no? So, your samples are fresh oil and rancid oil. So, the reaction for your fresh oil, for phenolphthalein, it turned to color, or the phenolphthalein turned to color red or pink, indicating that your fresh oil is basic. Ganon din sa methyl orange, it formed a yellow color with your methyl orange, that's indicating that it is also basic. And for the pH paper, it turned the pH paper to blue, indicating also that it is basic. So all 3 of these indicates that your fresh oil has the pH level, no, greater than 7. Next, you have rancid oil. Its reaction with phenolphthalein, your phenolphthalein turned into colorless or transparent, indicating that your rancid oil is acidic. For methyl orange, anong naging color? Color red. So, meaning acidic din. pH paper, the same red, indicating it is an acid. So, all 3 of the reagents or tests says that your rancid oil is, or your rancid oil has the pH lower than 7. Okay, so madali lang yung test for rancidity. Ang mahirap lang is mahaba yung kanyang explanation. Okay, next. Saponification. Okay, so in saponification, this is not actually a test. This is a procedure to produce a liquid, what? A liquid soap. Kasi yung liquid soap, yun yung gagamitin nyo para sa test or for the properties of soap test, like salting out and formation of fatty acids. Okay, so, may iba pa ba? So, yan. And insoluble soaps. So, ginagamit no, unlike yung sa iba na ang nagpe-prepare is laboratory, on saponification, you will actually know, if it is a face-to-face class, you are the one who will be making your soap. Okay, so before, in our class, my class actually performed this and naka-form talaga sila ng matigas na or solid soap. Okay, so una-una, liquid soap, and then by salting out, naka-form sila ng matigas na soap. May iba ring palpak. Okay, so hindi tumigas yung white substance na nilagay sa maliit na posporo. Okay, so yun doon yung kasi lalagyan ng posporo. Lalagay nyo yung white substance sa na-form from salting out, and then you wait it, no? Iiwan mo siya ng how many days, and then you wait for it to dry, and then yung matigas na product, yun na yung sabon. So, ginagamit-gamit nila. So, yung iba, gumamit ng iba-ibang types ng oil, no? So, dito ko sa sample natin is coconut oil. Pwede kasing gumamit ng ibang types ng oil to produce different kinds of aroma. Pero, yun nga. So, pwede nyo rin siya lagyan actually ng perfume. So, kung gusto nyo mabango siya. Pero, I don't know if that work actually because hindi ko naman inamoy isa-isa yung products ng class. Pero, yun. Nakaproduce sila. Yung iba palpak. Hindi tumigas yung kanilang white substances coming from salting out. Okay? So, ilan lang yung pwede nang magbenta ng sabon or whitening soap. Yun, ginawa nila. Yun siya. So, maganda sana if we can perform this. You've actually missed out on something very interesting, a very interesting laboratory experiment. But anyway, we will still have other classes. So, maybe, na-experience niyo siya someday. Okay, saponification.
Ano requirement yung pinakuha ang mga estudyante ng ano?
Okay. Sorry for the interruption, class. I was being asked. Okay, saponification. Let's go back to saponification. Okay. So, in saponification, you will weigh 1.5 grams of fresh coconut oil in a dry beaker. Add 10 ml of 10% alcoholic KOH or potassium hydroxide. So, ito yung alkaline na ginamit no, for the formation of salt. And then, cover the beaker with a watch glass. Fill the watch glass with crushed ice. So, kailangan nyo ng ice dito, class. For the globules, okay, remove. So, remove the watch glass, drive off the alcohol, and add 20 ml of water in the gelatinous mass. Okay, so, ang final product mo dito sa step number 2 sa procedure is actually a gelatinous mass. No? Tapos, you will add water, 20 ml of water to it in order to form a liquid soap. Okay, so the liquid soap or the solution of the soap, kapag solution, liquid yan, class, use the soap solution for the test on properties of soap. So, yun yung gagamitin mo na solution. Okay, so what is saponification? The saponification is turning fat or oil into soap by reacting with an alkali. So, ang ginamit natin na first alkali, KOH. So, objective niya is to form soap from lipids. So, yung lipids natin dito coming from the coconut oil or fresh coconut oil. So, dapat class, fresh yung ginagamit na coconut oil ha. for your saponification if ever you want to perform this in the future. Okay, so hindi rancid oil class kasi mabaho na siya. Okay, so dapat fresh coconut oil. Principle, saponification is the process of hydrolysis of oils or fats with alkaline. Okay, so kapag pinaghalo mo yung alkaline and your lipids, magkakaroon ng hydrolysis, resulting to glycerol and salts of fatty acid. So, yung salts of fatty acids, ito na siya yung soap mo, okay? So, can be used in separation of saponifiable materials from unsaponified. So, when you say saponifiable materials, ito yung mga materials na suitable for soap making, okay? Okay. So, reaction natin you have here, triglyceride, structure niya. And after hydrolysis, okay, with the addition of your KOH, it will form glycerol plus yung inyong sodium palmitate. Or hindi ito sodium ha, kasi yung example kasi namin last year class, sodium or sodium hydroxide yung ginamit. Pero dito is KOH. So dito dapat ang name nito is potassium palmitate. Okay? Potassium palmitate. Kasi K, okay? KOH ang ginamit mo na KOH ang ginamit mo na alkaline, okay? Or base. So, ayan. So, diba, nahiwalay itong structure na ito. And then, you will form this one. Dito ka mag-add ng K. So, KO, C double bond, oxygen, CH214, and CH3. So, itong potassium palmitate is the liquid soap. Okay, so reagent natin, you have potassium or 10% alcoholic potassium and water. And then, for the sample, 1.5 grams of fresh coconut oil. So, ano ba yung action ng oil? Ng ating soap? Soap can be defined as mineral salts or fatty acids. Bakit? It is a combination of your fatty acid and a salt coming from your strong base KOH or NaOH. So, the soap is soluble in water but insoluble in ether. Soap works on emulsification of oils and fats in the water as it works to reduce the attraction surface of the solution. So, emulsifier yung ating soaps. Why? Ano ang emulsifier? These are substances that tends to mix, solutions that are not supposed to mix. Just like your water and oil. Hindi sila naghahalo, di ba? Kasi may hydrophobic part yung inyong oils. Tulad neto. So, yung bilog-bilog dyan na maliliit na pink, that is yung maliliit na color pink na bilog, those are the water-loving part. Okay? So, yung head. Okay? So, ito yung hydrophilic part natin. And then, yung tail niya ang hydrophobic part, meaning ayaw ng tubig. Okay, so works on emulsification of oils and fats in the water. Okay, so it will emulsify, your soap will emulsify your oil and the water, no? Imimix niya yung unmixable water and oil. So, ito siya. For example, gaano ka-hydrophobic yung inyong oils. When an oil droplet is on the water, ganito ang mukha niya, micelle, okay? So, sa labas yung water-loving part to interact with the water, and sa loob yung tails, which are water-filling. So, tinatago sila sa loob. Kapag kabaliktaran, kapag nag-drop ka naman ng water doon sa inyong oil, ang nangyayari, the oil ang mag-interact pa rin sa kanya, the one that interacts with the drop of water is the hydrophilic part or the water-loving part. So, nabubuo pa rin. Kaya, nagkakaroon or your water when dropped to oil will form globules din, bilog din, kasi kita nyo, the oil forms a barrier or a circle barrier doon sa water. Kaya nagkakaroon ng droplets of water. And nandito, droplets of oil din when in water solution. So, how does your soap act when there is grease present in your clothes or dumi, no? Tandaan class, most pathogens or most microorganisms are what? They are lipids, okay? They are composed of lipids. Kaya nga, nadidissolve sila in the presence of organic solvents. Kaya, yung kapag gusto mong linisin ang kamay mo, magamit ka ng sabon or what? Or alcohol. Okay? Kasi your lipids and the microorganisms or pathogens will be dissolved doon sa inyong alcohol because your alcohol is an organic solvent. Okay? So, for example, meron kayong fabric, greased fabric, or a fabric with nalagyan ng oil. No? So, ngayon, gusto nyo siyang sabunan. Gusto nyo tanggalin yung grease sa fabric. So, lalabhan mo siya, di ba? So, nangyayari doon, yung maliliit na molecules ng soap, okay, yung kanyang tail will be dissolving doon sa grease. Bakit? Because your grease is oil, di ba? And the tails of the molecules of soap are actually oil loving, okay? Or they hydrophobic sila. So didikit sila doon sa grease found in the fabric. Now after that, kapag lalabhan mo na siya or kapag kinukusot mo siya, yung inyong the molecules of the soap will turn back, no? Will return to its original form, which is a micelle, and then dala-dala niya na yung grease found on the fabric. Kinuha na nung tails, nung structure ng inyong soap, yung grease na nanggaling sa fabric. So, nakita nyo, clear na yung fabric kasi yung grease nandoon na sa hydrophobic part ng inyong soap. Ha? So, itong dulo nito, yung dulo ng inyong soap molecules, yan, yung mga maliliit pink, no? So, yan yung pinakita ba dito? That is ito siya. Ito yung reactive part, okay? Oxygen and Na. Or dito sa sample natin, KO or K, no? KO. So, bakit ito ang reactive part? Kasi negatively charged siya. Okay? Meron siyang charges. So, tandaan, kapag may charges, they are polar. They are very reactive with the surrounding water molecules. Okay? So, since may charges siya, kasi coming from this, this is the hydrophobic part, diba? And this is the head of your soap molecules. Okay? So, meron siyang negative dito na charge, meaning this is the head, this is the water-loving part, and this is the hydrophobic part. Now, dito, ayan. So, ito yung mag-interact with the water, and ito yung, the tail will be the one interacting with the grease found in the fabric. Na after mo siya kusutan, yung fabric, dinadala na no tails or nakakulong na sa tails ng soap molecule, which is hydrophobic, yung grease galing sa fabric. Okay, so natatanggal niya. Yan yung action niya. Okay, first, it will dissolve in the grease. Then, after washing, it will go back to its original form, which is a micelle. And contained in the micelle is the grease coming from your fabric. So, after that, after hand washing or after nyo siyang kinusot-kusot, yan. Or after nyo siyang nilagay sa... Okay, so yan na. Clean fabric na siya because dala na nung sabon yung grease and dirt, no, found on the fabric. So, yan yung action ng inyong soap. let's go to salting out. Okay. Don't remember that the goal of the salting out is to make your or your solution soap or your liquid soap into a solid soap by adding salt or NaCl. So the objective to investigate the effect of salt or NaCl on soap solubility. So principle, to get the soap out of solution by salting out, when added solid NaCl to, or when you add NaCl or salt to the liquid soap solution until it was saturated, this is saturated, the solid soap will be separated in the form of insoluble white substance and floats above the surface. So kung ito na yung i-collect nyo class, and then i-shape nyo siya in a container, and then katagalan it will solidify. Okay, so okay, so i-saturate mo yung inyong fluid or liquid soap by using the salt, kaya nga salting out. Okay, and you will produce a solid soap and it will be separated. Okay, mamumuo siya ng white particles or white substances and it will float above the surface of the solution. Yun yung i-collect. Okay, so result niya ng salting out, ang sample mo is salt solution, your reagent is salt or NaCl, the reaction will form crystals or white substances that smells like coconut. Yan na yung aroma kasi galing sa coconut oil yung inyong soap. Kaya ang amoy niya is also like a coconut. Okay. Formation of fatty acids. Okay, so dito, ang nangyari, imbis na NaCl ang i-add mo, ang inadd sa formation of fatty acid is 10% HCl. Okay, so sample is soap solution, reagent is 10% HCl. Ang reaction niya, cloudy ang solution and it formed bubbles on the walls of the test tube. Okay, using a ruler, measure the length of the bubbles. I-measure nyo kasi yan, class. Compared to the detergent one. So, ito siya optional lang ito. Hindi naman siya nakalagay doon sa ating laboratory experiment procedure. Pero, ginagawa ito sa class if ever. I-compare mo yung formation ng bubbles na na-form from mixing your soap solution with a strong acid. So, mas marami, syempre, yung na-form sa detergents because detergent is a much more stronger type of soaps, no? Compared to yung ginawa nyo na soap solution. So, mas mahaba yung length ng bubbles na na-form in the detergent. Okay, next. Insoluble soaps, this is the last test, no? So, objective, to investigate the effect of different cations on soap solubility. So, ano yung kanyang procedure? Prepare 2 test tubes, each containing 4 ml of distilled water and 1 ml soap solution. Okay, so nilagyan mo na naman ng distilled water yung soap solution. And then, on each test tube, you will add either 5% of calcium chloride solution and 5% or 5 drops of 5% magnesium chloride solution in test tube number 2. So, you will investigate here kung ano yung magiging effect kapag nag-add ka ng cations to soap solution. Okay? So, ang nangyayari, ano ba kasi yung cations? Remember, your magnesium, calcium, lead, and iron, ano ang kanilang charges? Positive. Kaya ang tawag sa kanila is cations. Okay? So, ano yung mangyayari kapag nag-add ka ng cations doon sa inyong soap solution? So, principle, calcium, magnesium, lead, or iron ions replace the sodium and potassium or potassium ions present in the soap, which results for it to be insoluble in water. So, sabi natin kanina, your water or your soap is soluble in water. Bakit? Because your soap, the structure of your soap has a negative charge and positive charge sa dulo or sa head. So, soluble sila sa water and at the same time, they are also soluble in oil. Parang double double property no, yung inyong soap. So, balimbing siya ba? Soluble siya sa water, soluble din siya sa oil. Kaya, maganda siyang panglinis or pangtanggal ng grease. Okay? So, anong mangyayari kapag palitan mo when you replace the sodium or the potassium, in our case, potassium, di ba? Kasi potassium or potassium hydroxide yung ginamit natin sa formation ng soap ninyo. So, anong mangyayari if papalitan mo yung potassium ng other cation such as calcium, magnesium, iron, and lead? Okay? Sila ay positively charged. So, ang nangyayari dyan, imbis na soluble yung inyong soap in water, it will become insoluble. Okay? So, nawawala yung property or yung soap property ng soap. Okay? Nawawala yung cleansing property ng soap when you replace sodium and potassium with other cations. So, you call that as hard water. Or, ito yung hard water. This is water containing quantities of calcium, magnesium, and iron. So, this is difficult to produce foam or bubbles. Okay? So, yung hard water natin, yan yung rain. Okay? Napansin nyo, kapag pinapaligo nyo yung ulan, kapag nagsasabon ka, hindi natatanggal yung sabon. Bakit? Kasi yung water or yung rainwater is a hard water. It contains calcium, magnesium, and iron. Or meron siyang mga cation sa kanya. So, nangyari doon, the magnesium, the calcium, or other cations will replace the sodium and potassium on your soap. Kaya, hindi na nadidissolve yung salt sa water. Okay? Sa tubig ulan. Kaya, madulas mo kapag pinapaligo mo siya. Kahit ano pang lugod-lugod mo, hindi pa rin mawala or hindi naalis yung salt or shampoo sa katawan. Because this is the reason why. Meaning, yung tubig ulan, it contains cations and it is called a hard water. A hard water will always contain cations such as calcium, magnesium, and iron. So, mahirap mag-form ng bubbles, di ba? Pansin niyo. So, reaction niya, you have sodium soap. Kapag in-add mo siya with calcium sulfate, napapalitan, no? So, nagiging calcium soap and napapalitan yung calcium and sodium. So, nagiging calcium soap and sodium sulfate. So, ang original, you have soluble sodium salt or soap plus your calcium cation. Ito ang nangyayari. So, yung cation, papalitan niya yung Na. Yung cation will be connecting to another fatty acid. Okay? So, hindi katulad doon sa Na na nag-stay siya, no, unconnected. Your calcium will connect with other fatty acids. So, anong nangyayari? Wala na siyang head. Diba yung head the head part of the soap molecule is the one reactive with water. Now, if pinalitan mo siya ng calcium, ang nangyayari, it will bind with another fatty acid. So, both ends, left and right, are hydrophobic. No? Hydrophobic na sila. Wala nang reactive with water. Kaya, hindi na siya soluble in water. Kasi hydrophobic part or hydrophobic tail, and then the left side, ganun din. So, you call this as insoluble calcium salt or scum. Yung scum, yun yung mga naiiwan na puti na particles sa tubig kapag nagugas kayo ng kamay. Okay? Or, napansin nyo yan, yung kapag naiwan mo yung sabon or nagugas ka and then may balde, no? Yung nag-form sa taas ng water na parang puti-puti na particles, yun yung scum. Okay? Insoluble calcium or insoluble soap. Okay? So, result natin, lahat ito sila is positive. Okay? Soap solution with calcium chloride, soap solution with magnesium chloride, detergent with calcium chloride, and detergent with magnesium chloride. All will form white precipitate or cloudy solution. Okay? Nagiging cloudy yung solution and then merong scum. Yung white precipitate dito, yan na yung tinatawag natin na scum. Okay? So, pwede sa exam, pwede ko kayong I will make you write the reaction between the soap with KOH, no? KOH salt or potassium salt or soap, and then mixed with magnesium chloride. So, anong magiging product? So, parang ganito rin siya, class. No? Yung gagawin ninyo. Bigay niyo yung reaction nito. So, pwede yan sa quiz. Papagawin ko kayo ng ganyan. So, dito ang sample kasi natin is calcium and sodium. So, anong nangyayari if KOH, no? Or soap galing sa KOH na alkaline. So, K, potassium soap plus magnesium chloride. So, anong mangyayari doon? Okay, gagawin niyo yan siya. So, for preparation. Okay, so that's the explanation for laboratory experiment, lipids, or experiment number 6, lipids. So, I would just like to apologize if medyo sabog si ma'am. Wala kasing tulog si ma'am. So, and medyo lutang ako class. Pero I hope that my explanation, some of my explanation are understandable naman. Okay? So, I hope you watch this video. Okay, I will just replace the PDF found on or uploaded on your classroom. Okay? Palitan ko lang siya ng corrected na. Alisin ko yung mga corrections. Okay? So, you just wait for that. But, for now, okay, watch the video. And that's all. So, that's the end. Bye, class. See you again on the next video. Bye!